Okay, so here we are looking at some code, some text on the screen here, and this is normal programming fare. This is just some code that I've got. And looking at it, I need to keep a lot of this in my head and remember where things are. And that's normal. That's how all programmers do it. Nothing special there. But wouldn't it be cool if I could take this code and somehow move it into the physical world so that I could see it and see the actual logical flow between parts of the code and stuff like that? I'm gonna do that now. So we're gonna go over here to here, and I'm just gonna pull that code off the screen there and make it a little bigger. Now, what we're seeing here is this exact same code, but we're seeing the actual logical flow of how it works. What I can do is I can take any part of this code and I can move it and I can collapse it. And I can expand it out. And I can see all the functions in it. Or if I wanted to, I could actually expand it all the way out and see everything it does. But this is little, right? I mean, this is little, and I can put it on my desk if I wanted to. And if I got real close, I guess I could read all that. But what I could also do is I could expand this and actually stick it in my room. So let's do that. Now, the reason you might want to do something like this is a little on the crazy side, I admit, is because it allows you to use your spatial awareness to understand how code works. So we're going to take this same function here. I'm just going to walk right over here. Excuse me there, Zoe. I'm going to set this right here. Okay, so from here, I can see that this one class called Flare does a number of things. Let's take a look at awake. So this is the first thing that happens in this code. I'm just going to walk right over here. If I expand this out one level, I can see this right there. And actually, incidentally, if I go look at the code itself, there's my awake function, and it does exactly that. Okay, well, that doesn't actually help me too much. That's exactly what's on the screen. But what I can do is I can take that same code and I can say, okay, knowing that, let's expand it all the way out and see everything it does. Okay, so this is what that code's actually doing. It's going to do this stuff. When it calls load positions, here's what the load positions function looks like. And here's what it does and all the things it does. And this is the order in which it does them. And the really cool thing here is this is hierarchical. So if I move this around, it's going to move all that. If I move this around, it's going to move all that. And that allows me to see, for example, did I remember to set this properly before I actually used it? Did I, are these things initialized before I'm reading them, like these local positions, things like that? I could very easily take that and go look and see where in the code it's being accessed. So right here, this gives me the ability to see how the code actually kind of fits together and use my spatial awareness and my environment itself to kind of help me create these memory hooks that I can stick things on. And it works really well. It's shocking how easy it is to literally walk around your code and look at it big. And for some reason, I don't know if this is because when we're kids, we're given books that have giant letters or what, but you walk around, you look at stuff like this, and all of a sudden it's easy. It's a lot easier than when it's just text on the screen. And you can see the logical progression of things. So it's a lot easier to keep track of, did this thing actually happen in the order I think it happened in? So for example, if I'm having a problem with the detach function here, I can pull this out. I can see that it does a ton of stuff, but at the simplest top level, it looks like it really isn't. You look at this and think, okay, well, it's not actually doing too much stuff. But there's an if statement here at the bottom. Hold up, that's doing a lot of stuff. Oh, it just does calibrate, start, and move. Okay, well, so calibrate, start does. Oh, that just calls another function, calibrate, start. Let's see what that does. And so the ability to kind of take all of that data and just boom, shoot it all out and then see it It's pretty damn incredible how your brain can process this so much better than text on a screen. So if you've seen the other videos, you know that I'm doing a beta run of this, the VR version. This is the VR version of a desktop app that does the same thing, but in a window on your desktop. I am opening this up this week to beta testers. We were trying to do it over the weekend, but it's programming. We had some last-minute bugs. But if you're interested in getting in on the beta test, please let me know what you think, and shoot me a personal message. Let me know, and I will get you in. You'll need an Oculus Meta Quest 3 headset. That's what we're doing this in right now. This will be on the Apple Vision Pro as soon as that actually ships. But for now, the only way to do this is with a Meta Quest 3. We do have a Steam VR version coming up soon, which is not available yet. It just doesn't have pass-through. It's just the this rate VR version, which looks like kind of like this. Same concept, only difference is it's just you've got an environment that you're in. And it's got a ton of other cool features that we're going to get to in other videos, and I'll be showing off this week. But I just wanted to show you that. You don't have to have a giant environment to use this in. You can actually just use it on your desktop where you're sitting. But I do recommend walking around just once, just because it's fascinating how well it works. All right. Thanks. Let me know what you guys think, and I will see you later. Have a great day.